Hey team, I'm Maddie. Welcome to ScienceSideUp, and today we're going to talk about the history of programming and the very first programmable machines. Well, before we get into anything else, we need to define a couple terms. Specifically, what do I mean when I say a programmable machine? Well, a programmable machine is a machine that can perform different tasks based on different inputs. So, for example, here is my stand mixer. I love my stand mixer so much. Her name is Tabitha. But Tabitha is not programmable because she can only do one thing, and that's have a motor that spins. So this is an example of a non-programmable machine. My sewing machine, on the other hand, is an example of a programmable machine because when I just turn it on, it sews a straight line like this, but then I can press a button, right? I can give the machine an input, and that causes the needle to move, and now when I sew, the stitches look like this. So I get a different output, in this case stitches, for a different input, in this case pressing a button. If you've looked at the chalkboard behind me, you might have guessed when the first programmable machine was invented. And so this is before Alan Turing, this is before Ada Lovelace, before Charles Babbage, and this is before the United States was a country. The very first programmable machine was invented in 1745. And of all things it could have possibly been, the very first programmable machine was a loom, a giant loom for a textile factory in France. Playing here should be a video that I took in Ecuador this last summer of an indigenous family that has a home industry of traditional weaving. And so you'll see that you have all of these vertical strings. This is oftentimes wool, maybe it's cotton or even a synthetic fabric, but the loom is strung with all of these vertical strings based on whatever pattern you want to make. When we asked the family, they said that for this type of loom, it takes them something like 2 days to string the loom for a specific pattern. And then someone comes between and they have this wooden, sometimes it's called a shuttle or a boat, and then the horizontal string is attached to that, and you kind of throw it between those vertical strands. You throw it back and forth, and as you're throwing it back and forth, you raise or lower different parts of the vertical strings via foot pedals. So you're kind of weaving different patterns. You're utilizing different parts and different colors of those vertical strings to make a pattern. And I actually have a beautiful, beautiful piece of fabric that this family wove. It's a little shawl here, and I'm gonna wear it for the rest of this video because it's gorgeous and it's kind of cold in my garage, and I'm gonna carefully not hit or obstruct my microphone. Imagine that it's the mid-1700s and you own a textile factory and you are making not a pretty shawl like this, but you're making huge pieces of fabric, right? Like big bolts of fabric that you sell, right? And you have incredibly intricate patterns. Here are some examples of cloth patterns from that time period. I got these pictures from a company that sells replica period fabric, and you can find their link in the description below. So it's gonna take days and days to string your giant industrial sized loom to make each of these. And so every time you change pattern, you're losing days of productivity. And so this brings us to what's known as the Jacquard Loom. The first iteration of what we now know as a Jacquard loom was actually invented by a man by the name of Jacques de Vincennes. Name should be appearing right here because I don't speak French. And he kind of had this first idea for it and a prototype in 1745, which is where we get this date from. It wasn't put into wide use until about 1804 when Joseph Marie Jacquard improved on his design and made it workable for actual production. How does a Jacquard loom work? Well, instead of every time you want to use a new pattern, you completely restring the loom, you go ahead and have the loom strung, sort of think about it as with all possible patterns. And then it's fed a punch card, which there's a machine that reads it. And so think of it as this is a binary system, right? The paper is punched or not punched, corresponding with the lever on the loom being up or down, right? You could maybe even think about this as a 1 or a 0 if we were going to apply that to modern programming. So the card is punched or not punched for up versus down. I might have that backwards, I'm not completely sure. And then the paper code is fed through the machine, causing it to automatically raise and lower the correct strands so that then the shuttle can be thrown through. Now, it's still being woven, right, in the traditional way, but the up and down part, and you don't have to change out the whole string, right, the whole vertical setup every time you want to change a pattern. And so this is absolutely the basis for modern programming that was built upon by the idea of Charles Babbage, Ada Lovelace, and moving forward. Now you might be thinking to yourself, okay, well that's all well and good, right? But really, how powerful can punch cards possibly be? Well, some of you might already know this, but the very first computers worked off of punch card programming, the very same system initially developed in 1745. In fact, here's a picture of one of my personal science heroes, Margaret Hamilton, standing next to the physical punch cards, the physical code, right, that got us to the moon on Apollo 11. Our earliest computers that did such amazing things like get us to the moon were programmed on punch cards, the same technology that operated a loom. So I'm gonna say it here and I stand by this. Brocade got us to the moon. Okay, team, that's all I have for you guys today. I hope you liked this video. Welcome to all of my new subscribers. I'm really glad you guys are here. If you haven't subscribed, consider hitting that red button right down below. And I will see you all next time. Okay, bye, team.